Okay, hello again. This is the questions and answers on chemical bonding, and let's start with the first question. I hope that you have tried these questions. The nucleon number and proton number of the lithium atom are shown by the symbol this. What is the correct symbol for the lithium ion? Now, when lithium wants to make an ion, lithium is in group 1. It has 1 electron in its outermost shell. When it wants to make an ion, it loses that electron in the outer shell. Now, when it loses the electron in the outer shell, that means now it has extra positive. So, the answer should include Li positive. Now, when it loses an electron, does the atomic number change? We said basically the atomic number, which is the smaller number, is the number of protons. Did we change number of protons? No, we didn't. So the small number or the number of protons is still 3. Now, did we change the mass number or the nucleon number? The nucleon number or the big number is the number of protons and neutrons. It has nothing to do with the number of electrons, and the protons and neutrons did not change, so the mass number is still the same. So the lithium ion has same atomic number, same mass number, just has an extra positive charge. Okay, next question. Which two elements react together to form an ionic compound? Remember, an ionic compound is between a metal and a non-metal. Now, a metal has how many electrons in its outermost shell? We said a metal is in group 1, 2, or 3. So it has 1, 2, or 3 electrons in its outermost shell. So the metal, the element in front of us here, that is a metal, would be X. It has 1 electron in the outermost shell. Now, I want the X to react with something that is a non-metal. So the non-metal is something that has 4, 5, 6, 7, or 8. These are non-metals. But remember that the one that has 8 electrons in its outermost shell is in group 8. Does group 8 form any compound whatsoever? Remember that anything in group 8 has a full outer shell, so it doesn't need to lose or gain any electrons. So it does not form any compound. So T is out of the question. So I'm left with either X and R or X and Z. Which one is available to us in the choices? X and Z. Okay. Element X forms an acidic covalent oxide. Now, acidic covalent oxide means an oxide of a non-metal. Which row shows how many electrons there could be in the outer shell of an atom of X? Now, if we're forming covalent oxide, means it is an oxide of a non-metal, means the non-metal will have how many electrons in its outermost shell? It will have 6 or 7. Anything that has 1 or 2 is a metal, not a non-metal. And to be covalent, I have to have a non-metal. Okay, so it is C. Which molecule contains only single covalent bonds? Well, you need to be familiar with the dot and cross diagrams of each of these. So let's go through dot and cross diagrams for each one. Now, to have chlorine, we said chlorine, each chlorine has 7 electrons. It needs only 1 from the next chlorine. So they're going to share 1 pair of electron. 1 pair of electron, that is what we call a single covalent bond. But carbon dioxide, we said carbon dioxide, each oxygen needs 2 electrons from the carbon. So they're going to share 2 pairs of electrons with each oxygen. And that means I have double covalent bonds. Nitrogen, N2, each nitrogen has 5 electrons in its outermost shell. It needs 3 from the next one. So it's going to give 3 and take 3. That means we're sharing 3 pairs of electrons, and that is a triple covalent bond. Oxygen, each oxygen has 6 electrons in its outermost shell. It needs 2 from the next one, so it is sharing 2 pairs of electrons, and that is a double covalent bond. So which one has single covalent bonds? It is the Cl2. Okay? Which diagram does not show the outer shell electrons in the molecule correctly? Which one do you think is not correct? Now, A, there's nothing wrong with A because hydrogen, each hydrogen has 1 electron. It's going to share 1 from the other one, so that is correct. B, there is nothing wrong with B because the chlorine has 7 electrons of its own and it's going to share 1 with the hydrogen. C, there is nothing wrong with C. Carbon has 4 electrons. It needs 4 more, so it is sharing with 4 hydrogens. But what is wrong with D? Can you see what's wrong with D? There are no outer shell electrons for the first chlorine. Remember that each chlorine must have 7 electrons of its own. The electrons around the first chlorine are not shown, so that is the wrong diagram. Okay, the diagram shows part of the lattice structures of solids X and Y. X, O, and dot represent particles of different elements. What are the types of bonding present in X and in Y? Remember, if I say what is X, you should recognize X as the ionic crystal lattice for an ionic compound. So X is an ionic compound. So my answer is B or C. Now what is Y? You should recognize that Y is actually graphite, and graphite is made up of carbons that are covalently bonded to each other. So the answer is B. Okay? Which statement describes positive ions? Positive ions have more what than what? You should realize that when something is a positive ion, it has more protons than electrons. 3 substances R, S, and T have physical properties as shown. What could be the identities of R, S, and T? Now let's take a look at this. First of all, R has high melting point, boiling point, but poor electrical conductivity. So R must be something, poor electrical conductivity as a solid. So R must be something that is ionic. Okay? Now S has higher melting point, higher boiling point, and it's still poor conductivity as a solid. So obviously both R and S are ionic, but which would be magnesium oxide and which one would be sodium chloride? Remember that we said when we compare between things with more charges, the one with more charges is the one that has higher melting point. So magnesium oxide, for example, magnesium oxide has magnesium with +2 and oxygen with -2, while NaCl has Na with +1 and the Cl is -1. So the one that has higher melting point should be magnesium oxide. So the one that is S should be magnesium oxide and R is sodium chloride. So my answer is C or D. Now, T, he says, has high melting point, high boiling point, so obviously it's a giant structure, and it has good electrical conductivity. So do you think it's graphite or silicon dioxide? Remember that graphite, we said, is the only non-metal that conducts electricity because it has free-moving electrons. Silicon dioxide does not have any free-moving electrons, so it does not conduct electricity. Okay? A covalent molecule M contains a total of 4 shared electrons. What is M? So I want something with 4 shared electrons. Total 4 shared. Remember that he could say 4 pairs of electrons or a total of 4 electrons that are being shared. So we're looking for something that has a total of 4 electrons that are being shared. That means 2 pairs of electrons. Which of these has 2 pairs of electrons? Well, let's see. Ammonia has single covalent bonds, 3 of them. Each of them has 2 electrons. So ammonia actually has 6 shared electrons. Do you understand that? That each line represents an electron from the hydrogen, electron from the nitrogen. So each line represents 2 shared electrons. I have 3 of them, so this is 6 shared electrons. What about HCl? I have only 1 bond, single covalent bond, so I have 1 pair. 1 pair is just 2 electrons. Okay, methane has 4 pairs of electrons, so that means we have 8 shared electrons. What about water? Water has 2 single covalent bonds. Each of them is made up of 2 electrons, so this has a total of 4 shared electrons. Do we understand that? Which structure represents sodium chloride lattice? Okay, sodium chloride is obviously something that is made up of sodium ions and chlorine ions. Now, which one is positive and which one is negative? You must realize that A is wrong because sodium is the one that should have a positive charge and the Cl is the one that should have a negative charge. So A is wrong. Now, B, I need positive and negative, and the sodium, remember that the sodium atom is smaller than the chlorine atom. So we have, or this ion, actually, we're talking about ions. So sodium should be smaller than chlorine, so the answer is B. We're not going to choose D because D is actually the structure of a metal, not an ionic compound. And C is wrong because the sodium ion is positive and it should be the smaller one, and the chlorine ion is negative and it should be the larger one. Okay, 3 substances have properties shown. What are X, Y, and Z? So let us look at the properties. X conducts electricity when solid and when molten. Remember that the only thing that conducts electricity when solid and when molten is a metal. So X must be calcium, not magnesium oxide, because magnesium oxide is an ionic compound. Okay, Y. Y is soluble in water and the solution conducts electricity. Now, soluble in water means it has to be the sodium hydroxide, not the magnesium oxide, because magnesium oxide is something that doesn't dissolve in water, while sodium hydroxide dissolves in water. Conduct electricity as a solution, so that will have to be sodium hydroxide, because calcium is a metal, it's not something that dissolves in water. Z only conducts electricity when molten, so Z is an ionic compound. So obviously my answer is B. Were you able to get that? Think about it one by one in the same way that we're thinking about it together now in order to get to the answer. Now he's saying diamond and silicon oxide both have giant structures. Which statements are correct? Let's take them one by one. Both substances are compounds. We said no. Diamond is not a compound, it's only made of carbon, so actually diamond is an element. There are strong covalent bonds in the diamond. Yes, there are strong covalent bonds in the diamond because we have strong covalent bonds between the carbon atoms. Silicon oxide is bonded ionically. No, of course not. Silicon oxide has covalent bonds between the silicon and the oxygen. So that is wrong. Both substances have very high melting points, yes, because they are both giant. So the answer is 2 and 4, which is C. Which statement about metals is correct? Okay, let's take them one by one. Layers of positive ions can slide over each other, making metals malleable. Remember that we said yes, that's why metals are malleable. Okay, what about B? Let's check whether B, C, D are wrong. Metallic bonding consists of a lattice of negative ions in a sea of delocalized electrons. He's talking about metals, and we said metals are layers of what? Positive ions, not negative ions. Now, metallic bonding consists of a lattice of positive ions in a sea of delocalized negative ions. No, it's positive ions in a sea of delocalized electrons. Metals conduct electricity because positive ions are free to move. No, metals conduct electricity because the electrons are free to move, not the positive ions. Okay, the diagram shows the structures of 2 forms of the same element. What are the reasons for using T in cutting tools and U as a lubricant? Okay, T, we use it in cutting tools because it is very hard. Now, it is very hard because what? Because each atom is held in place by strong covalent bonds, or it is very hard because each atom is held in place by, both A and B say very hard because each atom is held in place by strong covalent bonds, and that is actually correct. C and D say it is very hard because there are no electrons able to move. The fact whether that electrons are moving or not has nothing to do with whether it's hard or soft. Okay, so it's either A or B. Now, the layers in U can slide over each other because the covalent bonds are weak or because the weak forces between the layers. So remember that the layers can slide over each other due to the weak forces between the layers. So the answer is B. Okay, which statement is correct? Metal atoms gain electrons to form positive ions. Metal atoms what do? No, metal atoms lose electrons to form positive ions, so this is not correct. Non-metal atoms lose electrons to form positive ions. Non-metals gain, they don't lose. The charge on an ion is always either +1 or -1. Really? An ion has to be +1 or -1? It cannot be +2, +3, -2, -3? Yes, it can, so C is wrong. Group 1 ions have the same electronic structure as noble gases. Actually, when something in group 1 forms an ion, it loses 1 electron, so it has the electron structure of the noble gas before it, so D is correct. Do you understand that? Group 1 has 1 electron in its outer shell. If it loses that electron, then it becomes like the noble gas immediately before it. Okay, which row gives the total number of shared pairs of electrons in the molecules shown? So, we need total number of shared pairs of electrons. Remember that here we're talking about pairs. In the previous question, we were talking about total number of electrons. Here he's talking about pairs of electrons. Okay, nitrogen molecule. What does nitrogen molecule do? Nitrogen molecule forms a triple bond. Each bond has 1 pair, so actually the nitrogen molecule has 3 pairs of electrons, not 2. Okay, C2H4, this is how we draw C2H4. And the total number of shared pairs of electrons, remember that between each C and H you have 1 pair. So that's 1, 2, 3, 4 pairs. And between the C and C we have 2 pairs. So that is 6. So actually that is the correct answer. So let's look at carbon dioxide. Carbon dioxide has 2 pairs on this side and 2 pairs on this side, so that's 4 pairs, not 2. And methanol has 1, 2, 3, 4, 5 pairs of shared electrons, not 4, so the answer is B. Do we understand that? Okay, the structure of ethanoic acid. Which diagram shows the arrangement of outer shell electrons in a molecule of ethanoic acid? Remember that each line is 1 pair of electrons. A double line, like the one between C and O, means I have 2 pairs of electrons being shared. So, which one is correct? What's wrong with A? Is A correct or wrong? A is wrong. Why? Because the oxygen there doesn't have the rest of the 6 electrons. Remember that when we have oxygen, oxygen has 6 electrons in its outer shell. If it's going to form 2 bonds with the carbon, that means I still have the rest of the 6 on each of these oxygens. So he didn't put the rest of the 6, so A is wrong. B, he put the wrong number of oxygens, and actually the wrong number of shared pair of electrons between the C and O, where you should have a C double bond O. C, is C correct or wrong? C is actually correct. What about D? D, he has extra electrons on the hydrogen. He gives each hydrogen 2 electrons of its own, which is wrong. So your answer is C. Okay, X is a solid at room temperature. X has a high melting point, and solid X conducts electricity. Once he says solid X conducts electricity, that means we're looking for a metal. Now, which diagram shows the particles in a metal? Of course, you should realize that the diagram A is the one that could represent metals. B represents what? You should know that B represents ionic crystal lattice, C represents diamond, and D represents diatomic molecules, which are simple molecular structure. Okay? Okay. The structure of methanol is shown. Which diagram shows the arrangement of outer shell electrons in a molecule of methanol? Now, as he draws it, he wants a double bond between the O. That means between the C and O, you must have 2 pairs of bonding electrons plus the extra electrons on the oxygen. A doesn't have the the rest of the electrons on the oxygen. Oxygen has a total of 6, so the oxygen should be using 2 of its electrons to bond with the carbon, and it should have 4 left. Okay. What's wrong with B? B still has extra electrons on the hydrogen. Hydrogen only has one electron. You can't have two dots for the hydrogen. So B is wrong. What's wrong with C? There's nothing wrong with C. So C is the correct answer. What's wrong with D? D has extra electron on the oxygen and something that is not bonding on the carbon. So D is totally wrong. Okay, ethanol is a liquid at room temperature, boils at 78 degrees centigrade. Sodium chloride is a solid at room temperature. Which statement about the bonding in ethanol and sodium chloride is not correct? Okay, so if we say that ethanol is a liquid at room temperature and boils at a relatively low boiling point, that means that ethanol must be a covalent compound. So if it is a covalent compound, each ethanol molecule is held together by weak covalent bonds. Never say weak when you're referring to covalent bonds. Covalent bonds are strong, but the molecules could be held together by weak attractive forces. So I can have ethanol between each molecule and the next. There are weak attraction forces. So B is probably correct. So let's look at C. Sodium ions and chloride ions are held together by strong attractive forces. This is correct. Actually, remember, is he asking for the correct one or is he asking for the not correct one? So which statement about the bonding is not correct? So far A was the one that's not correct, because weak covalent bonds, we said you cannot refer to covalent bonds as weak, they're strong. So A is wrong. B is correct, C is correct. What is D? Sodium ions and chloride ions are held together in a giant lattice. That is correct. So A is the one that is not. Please pay attention. Is he asking for which one is correct or which one is not correct? Which row describes the type of bonding present in substances 1 and 2? Substance 1. Okay. He has different choices for substance 1. He's saying methane has ionic bonding. Is that correct? Methane, you should remember that methane is a bond between carbon, is a molecule between carbon and hydrogen. Both of them are non-metals. That means they're covalent, not ionic. Remember that ionic, one of them has to be a metal and the other non-metal. Graphite has ionic bonding. I disagree. We said graphite has covalent bonds between the carbon. Potassium chloride has ionic bonding. Yes, because potassium is a metal and chlorine is a non-metal. So when they form a compound, it is ionic. So both C and D are correct. Let's look at substance 2. So we've agreed that A and B are wrong. Let's look at C. Methane has covalent bonding. Yes, methane has covalent bonding. D says graphite has ionic. No, so my answer is C. Are you paying attention how to think about these questions? Okay. Substances with giant covalent structures can be used as lubricants and as cutting tools for hard materials. The diagram shows how the atoms are arranged in two giant covalent substances, X and Y. Which statement is correct? Now, if we're talking about X and Y, he's saying that X, can you look at X? X has layers with weak attraction forces between them. Y has layers with strong covalent bonds between them, okay? So only X is used as a cutting tool and only Y is used as a lubricant? No. A cutting tool has to be strong, and if X has weak attraction forces between the layers, that means that it is not strong, it's soft, so A is wrong. Only X is used as a lubricant and only Y is used as a cutting tool. Yes, I would agree with that. If he says X and Y are both used as cutting tools, that's not right, because X is not strong, it is soft. X and Y are both used as lubricants. I would disagree because Y is strong, so the answer must be B. Okay, which statement about copper, diamond, and silicon oxide is correct? Okay, let's take a look. Copper and silicon oxide have similar electrical conductivity. I would disagree with that, because copper is a metal that conducts electricity, while silicon oxide is a non-metal compound. It's a covalent compound that does not conduct electricity. In diamond, the carbon atoms are covalently bonded as flat sheets? No. In diamond, they are tetrahedral structure, which is not flat sheets. In silicon oxide, silicon and oxygen are covalently bonded as flat sheets. No. Silicon and oxygen also have a tetrahedral structure. The structure of copper includes a lattice of positive ions. Remember that the word lattice means a regular arrangement. So, yes, the structure of copper includes a lattice of positive ions. So, that's the correct answer. Okay. Questions from paper 4. The following table gives information about 6 substances. Which substance could have macromolecular structure similar to that of silicon oxide? We said macromolecular structure means large, giant, means high melting point, high boiling point. Now, similar to silicon oxide means it does not conduct electricity as solid or as liquid. So, from the table, which one has high melting point, high boiling point, and poor electrical conductivity, poor electrical as a solid and as a liquid? So, that is E. Okay? You can't choose D or B because they have low melting points. You understand that? Okay. Which substances are solid at room temperature? To be solid, it has to have a melting point that is higher than 25. So, A would be a solid. Is B a solid? No. B has very low melting point, boiling point. So, actually, B would be a gas. C is a solid. What about D? D is a liquid at room temperature because the melting point is low and the boiling point is high. What about E? E is a solid, very high melting point. So A, C, and D. Which substance could be a metal? Remember that a metal would have good conduction, both as a solid and as a liquid, and very high melting point and boiling point. So A is a metal. Okay, another question. Which substance could be aqueous sodium chloride? Okay, aqueous sodium chloride just means a solution of sodium chloride in water. And that means that the melting point and the boiling point in water would, if it is pure water, the melting point is what? The melting point is 0 and the boiling point is 100. But if I dissolve a little bit of sodium chloride in it, remember that it is just like putting an impurity in it. What happens to the melting point and what happens to the boiling point? Remember from a previous chapter that the presence of impurities in a liquid will lower the melting point and increase or raise the boiling point. So, which one has a melting point slightly lower than 0 and the boiling point slightly higher than 100? And if it is aqueous sodium chloride, that means you're dissolving an ionic compound in it. That would mean that it is a good conductor as a liquid. So obviously, we're talking about F. Which substance is an ionic compound? Now, ionic compound, we said it should have high melting point, high boiling point, conduct electricity only as a liquid, not as a solid. So that is obviously C. Which substances are liquid at room temperature? We said to be liquid. The melting point is lower than room temperature and the boiling point is higher than room temperature. So which one does this apply to? F and D. Okay. Diagram shows the lattice of a typical ionic compound. Explain the term ionic lattice. And this has 2 marks. So again, remember that an ionic lattice is giant 3-dimensional structure with regular arrangement of alternating positive and negative ions. Explain how the ions are held together by strong forces. We said in the ionic compound, it is held by strong electrostatic attraction forces between the oppositely charged ions or between the positive and negative ions. Give 3 physical properties of ionic compounds. Remember, is he talking about physical or chemical? He's talking about physical. That means you will talk about melting point, conduction of electricity, solubility in water, density, if it applies, things like that. So, if you have an ionic compound, remember that it has high melting point, boiling point, conducts electricity when molten or in solution, and it should be soluble in water. In most of the questions, you'll be required to draw dot and cross diagrams. So here he's saying strontium oxide is an ionic compound. Draw a diagram which shows its formula, the charges on the ions, and the arrangement of the valency electrons. Again, I'm going to remind you that the word valency electrons means electrons on the outer shell. Okay, he wants the valency electrons around the negative ion. The electron distribution of a strontium atom is this. Again, if he puts 18 in the middle, just ignore it. It is correct. Some shells can take up to 18. Okay. The important thing in the electron distribution is the final one. What does it have in the outer shell? It has 2 electrons in the outer shell. That's because it's in group 2. Now, when we draw this, we said we're going to draw the strontium, and the strontium is something in group 2. So it loses the 2 electrons in the outermost shell and becomes 2 positive. The oxygen has 6 electrons of its own. It's going to need 2 more. So it will take the 2 from the strontium, and that will give it an extra 2 negative charges. Okay, draw a diagram showing the arrangement of valency electrons in one molecule of the covalent compound germanium chloride. He's already telling me that it's covalent, and without even telling me, I should know that they are covalent because both germanium and chlorine are on the right side of the periodic table, and that means they are nonmetals. Okay, so we have germanium with 4 chlorines. So obviously I have germanium in the middle with 4 chlorines around it. Germanium is in group 4. It has 4 electrons. It needs 4 more. Each chlorine can donate 1 and take 1. And the chlorine has the rest of its 7 electrons around it. Do not forget to draw that. Okay. Draw a diagram to show the arrangement of valency electrons in one molecule of the covalent compound arsenic trifluoride. And again, he's telling me that arsenic has 5 electrons in its outermost shell, so it is in group 5. So I'm going to draw the arsenic with 5 electrons. It needs how many? It needs 3 electrons. Each fluorine has 7 in its outer shell, so it needs 1. So we need 3 fluorines to give 3 electrons to the arsenic. Do not forget that each of the fluorine has the rest of its 7 electrons around it, and the arsenic had 5. It's using only 2 for bonding, so it has 2 left that you should put up there on the arsenic. Okay? Okay. He has the structure formula of hydrazine, and he says draw a diagram showing the arrangement of valency electrons in hydrazine. Again, if he draws the lines for you, that's making it very easy, because you should know that each of these lines is actually a pair of electrons. So each hydrogen will give 1 electron and take 1 electron. And please remember that if he gives you a certain notation, so here he's saying the X should be for the nitrogen and the circles for the hydrogen. So make sure you stick to his notation. Sometimes he doesn't specify the notation, so you can choose your notation on your own. But if he does specify it, then you should use that in your diagram. So the electrons for the N are X's. We know that each nitrogen has 5, so it needs 3 more. So it's going to take 2 from the hydrogens and 1 from the neighboring nitrogen. It still has the rest of its 5. Do not forget to put the rest of the 5 on the nitrogens. Okay, valency of scandium is 3. Draw a diagram to show the formula and so on. So you're drawing scandium fluoride. So first of all, before you draw anything, please remember you need to decide, is this ionic or covalent? Now, scandium is in the transition metals. It's a metal. And fluorine is a halogen. So this is metal with non-metal, so this is ionic. So that means that the scandium will lose the outermost 3 electrons and become scandium plus 3. Each fluorine will have its own 7 plus 1 from the scandium, because it needs only 1, and that means I will need 3 fluorines. Each of them now has an extra negative charge. Okay, the melting point of scandium fluoride is very high. Explain why scandium fluoride has a high melting point. Remember that scandium fluoride is ionic, and we said ionic compounds have high melting point. Why? Because it has strong attraction forces between positive and negative ions that need a lot of energy to be broken. Okay. Describe the structure of silicon oxide. You may use a diagram. So in this case, you can describe it in words and you can draw the diagram. You have to describe it. You cannot just draw the diagram. Okay, it's a giant three-dimensional tetrahedral structure in which each silicon is covalently bonded to 4 oxygen atoms and each oxygen is covalently bonded to 2 silicon atoms, and that's how you draw it. Each oxygen should have 2 bonds and each silicon should have 4 bonds. Okay, please remember the description. This is a very easy question. If you get it, you just write the description of the structure. Okay, here is another diagram and he's telling me to draw the arrangement of valency electrons. Again, he specifies that the X are the electrons from carbon and the circle is the electron from hydrogen. So you should be able to draw something like this. If he has 1 bond, that means 1 pair of electrons. If he has 2 bonds, that means 2 pairs of electrons. Were you able to draw this correctly? I hope so. Okay, draw a diagram showing the arrangement of outer valence electrons in 1 molecule of methanol. And I'm telling you that methanol is CH3OH. And he specifies a certain notation, X for carbon, circle for hydrogen, dot for oxygen. So, this is how we drew it. We said each hydrogen can donate 1 and take 1. Now, the carbon needs 4, so it's going to take 3 from the hydrogens and 1 from the oxygen. The oxygen needs 2, so it's going to take 1 from the carbon and 1 from the hydrogen. Okay. This is another structure. How did you draw the dot and cross? It should look something like this. Each chlorine has 1 electron being shared with the carbon and the rest of the 7 surrounding it. And he specifies that the chlorine electrons should be X's. Now the carbon is going to share 1 pair with each chlorine, so it needs 2 more, so it will take it from the oxygen, and the oxygen needs 2 anyway from the carbon. Okay, do not forget to put the rest of the the rest of the electrons around the oxygen, because oxygen has a total of 6, it's going to use only 2 of them, so it has 4 more electrons that are not involved in the bonding. Okay, here he's asking for the diagram of lithium oxide. Again, this is metal with non-metal, and that means the metal will lose and become positive, the non-metal will gain and become negative. Here the oxygen needs 2 electrons, but each lithium can donate only 1. Each lithium is in group 1. So that means that I need actually 2 lithiums to give me 2 electrons to be given to the oxygen atom. And remember that now each lithium has an extra positive and the oxygen now has an extra 2 negative charges because it took 2 electrons. Here we're looking for selenium forms an ionic compound with potassium. And he's telling me that selenium has 6 electrons in its outermost shell. Outermost shell. So selenium has 6, that means it needs 2. Each potassium can give only 1, and that means I need 2 potassium ions. When they lose 1 electron each, they get a positive charge, and the selenium will gain 2 electrons, so it now has 2 negative charges. Okay, here this is the electron with a covalent compound, selenium chloride. Now, selenium and chloride, he's telling me that it is covalent, that means I have to share. So each chlorine, and he specifies the notation, each chlorine has 7, it needs 1, so it's going to give 1 and take 1 from the selenium. Now the selenium has 6, we already said it has 6 electrons in its outer shell, so it's going to take 1 electron from each chlorine, and it still has the rest of its 6 up and down there. Do not forget to put the outermost electrons that are not involved in the sharing. Okay, predict 2 differences in the physical properties of these 2 compounds. He's talking about the covalent selenium chloride and the ionic potassium selenide. Okay, so the potassium selenide will have, because it's ionic, it will have higher melting point and boiling point, and it will conduct electricity when molten or in solution, while selenium chloride will have lower melting point and does not conduct electricity. Okay. Remember, he's talking about physical, so I cannot say anything about reactions. Describe the bonding in a typical metal. So he's just telling me to describe what we have in a metal. You should remember that the metal has strong electrostatic attraction forces between what? Between the layers of positive ions and the delocalized negative electrons. Explain why there are attractive forces in a metallic structure. Remember that in a metal there is strong electrostatic attraction force between layers of positive ions and delocalized negative electrons. Explain why a metal, whatever, any metal, is malleable. We said, why is a metal malleable? The layers of positive ions can slide over each other when heated or hit with a hammer. Okay? Describe the metallic bonding in zinc and then explain why it's a good conductor of electricity. So remember that metallic bond is the strong attraction force between the layers of positive ions and delocalized negative electrons. Now, why is it a good conductor of electricity? Due to the presence of free moving electrons. And this is a diagram, and he says complete the dot and cross diagram for this. Were you able to do this? So the oxygen has a double bond with the nitrogen. Double bond means 2 electrons from this and 2 electrons from that. Okay? And the nitrogen has a total of 5. So it is going to use 2 to share with the oxygen, 1 with the chlorine, and it still has 2 extra electrons that you should put somewhere on the circle. The chlorine has 7 of its own and it needs 1, so it's going to give 1 and take 1, and you write in the rest of the 7. Okay, explain why any compound has a low boiling point. We said if it has a low boiling point, that means it has simple molecular structure, and that means it has weak attraction forces between molecules that need a small amount of energy to be broken. Remember that. This is what we use to explain why something has low boiling point or melting point. If it has low boiling point or melting point, that means it's not giant. That means it's a simple molecular structure. And if it's a simple molecular structure, that means it has weak attraction forces between molecules that need a small amount of energy to be broken. Okay? Name the type of bond that exists between atoms in silicon oxide. Remember that silicon oxide is made up of covalent bonds. Explain why silicon oxide has very high melting point. That's because these covalent bonds are strong and need a lot of energy to be broken. Explain in terms of attractive forces between particles why carbon dioxide has very low melting point. We just said if something has very low, that means it has weak attraction forces between molecules that need a small amount of energy to be broken. Explain in terms of particles why carbon dioxide is non-conductor of electricity, because it has no ions and no electrons. Okay, and this is the end of the chapter. So, study everything,